Let's go a little bit deeper into one of our variables, the age variable. And one of the things we can do with that variable is actually look at the average age of death for individuals that reported to this database. So if someone died, what age they were. Now, obviously, we can only do that for either people that are measured in years or days at the same time. So what we're going to do is build a selection that actually looks at both the outcome of death as well as the age units. So this should be very similar to what we did earlier, where we're going to do a two-part selection. So let's call this age death selection equals, and we'll do df outcomes equals death, outcomes equals death, and age units equals years. So this will give us a selection. And so now we have this new selection. And what we're going to do with this selection is we are actually going to create a histogram. So df age death selection patient age dot hist. All right, so this function right here in pandas is what creates a histogram. So histograms are very, very straightforward. Histograms create bins, so like this blue bar right here is going to be representative of everything between roughly 0 and 10, let's call it. Might be a little bit different, but that's the rough idea. Then on the y-axis, what you're looking at is the count of occurrences that fall within that particular bin. So how this can be interpreted, let's take an easy one. So this blue bar right here, let's say this blue bar is from roughly, let's call it 56 to 62. So that would be this bar. That means around 300 people died that were in that age range of about 56 to 62. So that's the interpretation of this. Histograms are used for a wide range of different tests. They are really kind of one of the best ways to describe a single variable, but frequently we need quicker things, right? So let's say that I am a doctor and I want to kind of get a better idea of when individuals are most at risk for dying to some sort of food-related issue. I could look at this. I could actually look at this histogram, but it's hard to communicate information using thousands of histograms when you might have a lot of different questions. So what's much, much, much more common is for individuals to get, the mean or the mode. So, for example, a doctor might be told individuals around the age 60 on average are at the highest level of risk. That is would be a reasonable sentence to say based on this data. So, we can obviously grab that if we want to out of pandas, right? We could calculate the mean of this. So I'm going to just copy this, paste this, and I'll go ahead and just type in mean. And there we go. So, right, the mean is just about 60, 59.3, or the mode, whatever our preference is. And there we go. So 60 looks like our most common occurrence of the mode. So these are, and you can see that right here, right? 60 would be the highest. So these are the ways that you can go in and kind of calculate those types of data points. Now, we want to make sure as data scientists that we are not misrepresenting a distribution when we give someone a mean. So in this particular case, if I gave someone a mean, right? If I go in and I write my report and my report says on average, individuals with an average age of 59 tend to be the most at risk. That is a reasonable representation of this distribution. As you get older than 59, your risk decreases. If you are younger than 59, your risk decreases a lot. The mean is obviously not a perfect representation because, you're at much higher risk as you get older. That's, clearly true from this chart. But as you go to the left, it's kind of a massive drop-off. And so the mean doesn't tell you that. All the mean tells you is that this is the most common age. So again, mean's not perfect. It doesn't give you all the information, but it's at least a reasonable starting point. Now, let's do something else. Remember, we dropped out the newborns, right? Everyone that wasn't at least 1 year old is not in this data frame. So let's do something a little bit different, and let's just look at all of the newborns in our database. So we'll do a newborn selection. Data frame of age units, and we'll do this one as days. So just a one-part selection in this case. We're not going to look at necessarily the newborns that died, just all of the newborns for this example. And then let's take a look at the histogram for this. So I want to contrast these histograms. Important to put parentheses there. There we go. So this is the histogram representing all of the different newborns and when those newborns had an incidence that they reported. Now here, let's do the same thing we did a second ago. Let's actually go in and let's calculate the mean of this distribution. So here we go, 24.4. So somewhere probably right about here. Now, in this case, the mean is much, much less meaningful, right? It's not representing the tallest bar here. It's not the age at which individuals, the kids are the most at risk, right? That would be here. The first few days of life is when they are the most at risk because that's when the most individuals actually reported an incident. Rather, the mean gets pulled in this direction because of probably this outlier, right? This outlier is going to result in the mean becoming larger than it would otherwise be. And so this is just a quick example of when a mean might not be the best way to communicate information, and this can have a lot of kind of other modeling and statistical ramifications as well. Let's take another example here. So let's look at, remember Kratom was the most deadly product we had in our database when we were looking. So let's do a Kratom selection, and I'm going to select based on product this time. And let's go ahead and just look at the mean here. So the Kratom selection. So data frame, Kratom selection, mean. Patient age. Make sure that we're getting this right. There we go. So the mean patient age within all cases where Kratom was reported is 33.4. So a little bit younger. So we could make the statement, right? If all the data we had was this mean, we could make the statement, okay, individuals that are around 33 tend to be the most at risk for having a negative reaction to Kratom. That seems like a reasonable thing to do. Let's take a look at the histogram. Here we go. So as you can see on the histogram, 33 was our mean. It's unclear if there was even a single individual, the age 33, that reported an incident with Kratom, right? So we don't have a very good representation at all from that mean of 33 for this particular distribution. So you just have to be careful when you're trying to communicate your data that you don't just look at kind of the means or averages or modes. You really do need to take a look at your underlying distributions to see if the ways you communicate data make sense. In the next video, we're going to start exploring this a little bit more in terms of models and how these types of issues can actually start to manifest themselves and cause issues when you're running machine learning models.